Hi everybody, welcome back to CAD1134 Week 6. Today's exciting. We're finally going to get into creating something in 3D. Now, there's quite a bit of material to go through today, so I'm going to go through the first set of slides, and then I want to get into the in-class exercise, and then we'll break halfway through to talk about the second set of slides. Then we'll finish off. I'll show you the third set of slides, and then we will talk about the homework assignment. Okay. So without further ado, here we go. There are some basic shapes that create all of our geometry. If you look around and you find some object around your desk, you'll find that it may be complicated, but in reality, when you break it right down, there are 7 shapes that you could use to construct almost anything. Okay. Now we're going to take advantage of most of these shapes as we are starting to create parts, and then there are some more complicated ways. And we're going to discuss them at the beginning of class. I don't expect you to create or understand all of the information about it yet, but know that these shapes are available. Here we have a little video where I show how to create some shapes. And so this first shape is just a rectangular prism. You can see that the function is to actually just draw these shapes in 2D and then extrude them up. And this is through the solids menu. The sphere obviously works a little bit different, but you see that we can just enter the radius once we have the start point. Okay, the wedge. The wedge, we set the base and then the height, and the angle is calculated for us. And of course, we have our drop-down menus, the same as so many other functions with AutoCAD. And here we're able to create a cone. And again, we're able to type these values in if we know them. I will have you note that I have tilted everything around, so I'm no longer just panning. I'm actually moving in 3D, and if you watch the view cube over here, you can start to understand how we're moving around in our 3D space. Okay, so that's just a taste of what can be done with some of these functions. Feel free to play around with it. That's the best way to learn, is to actually experiment. So once we create our basic shapes, there are things that we can do to modify them to create more complicated shapes. And we call these Boolean operations. And Boolean is something that's going to come up over and over again in this, not just this course, but the program that you're in. There are 3 basic Boolean operations. There's union, which is the same as adding. Okay, there's subtraction, which is in essence subtracting one object from another, and then intersection, which compares the two and takes the similarities. So in this case, I have a wedge and a toroid, and only the areas that are interfering are left at the end. Okay. There are several ways that we can do this, but here's a little video where I'm going to take some shapes and start to move them together, and we can then union the 2 of them. You'll see that it becomes one object. I'll then take this cube and move it in so that it interferes, and move it down. And then I will subtract this. And finally, I'll take all of it and put it inside the inside this sphere, and use the intersect to come up with a very complicated piece of geometry. And you can imagine here in a second that trying to create this piece of geometry without knowing how it came about would be very, very difficult. This would be a very complicated part to try to make from scratch. There are other modifiers that we can use. For example, we can take our cube here and use the shell command to make a box. One of the things that you can do with this is you can actually remove one of the sides so that it becomes an open box. We can also add things like fillets and chamfers, and that's super useful. We can also take our cube and use the press pull command to make a rectangular prism. Okay, so here press pull, and we're able to grab just a side and pull it down. We can also use a command called slice, and slice will allow us to take a solid part and break it into two pieces, and that is really useful. And so here I have a little video of using some of these commands. Okay, so here we're adding a fillet. The nice thing with the fillet in 3D is you can actually preview it before you commit to it. Okay, we'll add a chamfer, and you'll notice that by hovering over the corner, we can actually see what's in behind. Now we're going to use the shell command, and we'll once we set the width, we'll exclude the top face. And so we're able to turn this into a box, and you'll notice that it has a consistent wall thickness. As we go around the radius, the inside radius matches the outside radius. If, however, we put the radius on after, we don't have the same effect. What we end up with is a thicker wall if the radius is on the inside, or a thinner wall if the radius is on the outside. So we want to be really careful about when we use that shell command, that we are actually able to get all of our fillets in ahead of time. Now here I'm using the slice command, and I've created a line just as a working guide, and I've colored it so that you can see what happens when we split it in two, so it becomes obvious. Okay, so now I'm going to use the press pull command after I've moved it, and I'm just going to pull that over until it touches the other entity. And so this is a great way of taking a box and extending it, making it longer. All right. The next thing to talk about is rotate. And so you could see that while I was working in 3D, I was actually panning and rotating around in 3D. But one of the things that we're going to have to start to do is, instead of just thinking about rotating about a single axis, now we're able to or need to rotate in 3 axes. And so here I've created a little smiley, and I want him to be looking up into an angle. And so what I've done is I've created a line that represents my axis of rotation, and then I've rotated using the rotate 3D, able to grab him and rotate him up. And we're going to spend a fair bit of time on rotate 3D, but not right at this moment. Let me just show you how it works. So this line is on the XY plane. So this will simply take it and rotate it along that axis. And I've created another line here that is not on the XY plane. It is in free space. So here's our rotate 3D. So we've picked our object, we've picked a start and an end point to find the axis, and we've typed in an angle. And so I've rotated that across along the XY plane, but on an obscure angle. This time I'll use the free-drawn line that is in 3D space, and you can see that it's put it in some very unusual compound angle. Okay. So not an easy tool to get your head wrapped around, but very powerful. And again, the idea here isn't that you know how to use it or you're proficient at this point, but know that it is available to you, and we can start to look at how to apply it properly. Now there are some advanced extrusions. We talked about how the cube command, for example, starts by creating a rectangle and then it extrudes it up. You're not limited to those basic shapes. We can also use things like a spline, which is a continuous line, as long as it closes itself off to create any solid geometry. We can also use a polyline or take line segments and use the PEDIT to create a polyline. This, again, as long as it's closed, you can extrude, and so I end up with this kind of square heart. The sweep command is really, really useful for creating things like piping and wiring in 3D, so you can actually create a spline or a polyline of line segments, and I'll show you how to do that here in a second. Take a circle and then extrude it. It doesn't have to be a circle, but and then loft. Loft is a great way, if you can get it to work for you, to create some very ergonomic designs. And so here's a little clip where we take some geometry. Here's the spline. And we simply extrude it. Again, the trick is that it has to be closed. Again, a closed polyline, able to extrude, no problem. Note that when it's not closed, one closed entity, and I tried to extrude that, it came up as those like walls, and so those are actually surfaces. So we need to make sure that we use a command like Polyline or PEDIT to turn it all into one object so that it becomes closed. Okay. The sweep command is really cool. Again, I don't expect you to start off being able to run this, but note that it is an option for you. One thing that is important when we use the sweep command is that we can't, you can, but you don't really want sharp corners. So think about your bend angles if you're creating geometry for, say, a wire that's being bent. There's a minimum bend radius. So now we'll use the PEDIT command again to turn this into a single entity. And we'll do that by joining. Okay, so now it's all one entity. We're able to create the profile that we want to extrude. In this case, it's going to be a simple circle. And then we're going to rotate 3D so that this is actually perpendicular to the endpoint. When I recorded this, I was definitely having one of those days where things weren't really working for me well. So please don't feel bad when it happens to you, not if, that clicking on things isn't working exactly the way you wanted. But you will get there. Sometimes it's a little temperamental. So we're going to take the object, and then it asks for the sweep profile. And so we're able to create this wire widget. So very powerful tool. Consider using it if you have an application. It's worth it once you set it up to create some complicated geometry. Okay, so next we want to jump into the first part of the in-class exercise. And so I'm using the document that's been created for week 6, and we're going to follow through kind of step by step. So the first thing to do is let's get our AutoCAD open, and we will start working through this. And for today, I don't need the in-class exercise, so we're not going to spend a whole lot of time setting up our drawing for our exercise. So I don't care about filling in the title block, for example. Once we're in our workspace, the first thing that we want to do is we want to get a little bit familiar with moving around in 3D a bit. All right. And so the first thing is I want to set this up so that we can access some of our 3D tools. And what I'm going to show you first is how to open up that menu. So what we're going to do is this little pull down tab here, we're going to go down, and I want to open up or enable the workspace. It now gives us this option here, and you can see that we are in drafting and annotation. I want to click that, and I want to change to 3D Basics. Now we have access to all of these tools. Okay. The next thing is we want to be able to move around in 3D. And so when we press and hold the center mouse button, you'll see that we are able to pan around. We're able to zoom, and that's fine for 2D. Once we want to manipulate in 3D, we could use the view cube, That's kind of difficult because we need to always move over here. And now that we're used to just using the center mouse button as a pan, if you hold the shift button and the center mouse, you're able to rotate around. In this case, because there's nothing here, we're rotating around our origin point, our X, Y, Z, 0. Okay. If you use the control button, it's actually a pan 3D. All right. All right, so the first thing that we want to do is using the WCS. So what is a WCS? This is the world coordinate system. It's this 0, 0, 0 down here. And we know that we are in WCS because it's actually up here. And we're not gonna get into that a whole lot right now because that's a whole topic for another day. Okay. So we can let's start by creating a rectangle. Now, if you're key on using the drop-down buttons, you're going to want to go back to drafting and annotation so that you can find your rectangle. Or if you can recall, it's rec for rectangle. Okay, you just start typing rectangle. And we want our base point to be at 0, 0. And notice if I keep pressing the comma, I can now access the third position. So in this case, 0, 0, 0 is going to be the start point. And we want a box, a square that is 4, 4. And I don't have to use the third axis. It assumes that you're drawing on the XY plane. Okay, and so now we can move this around to where we want. Notice that we now have that green dot. That's the center of our drawing. Okay, and now we can extrude it. We can grab this entity and extrude this up. And there's a couple ways. We can use the little button up here, and we can grab this, and we can press enter once we've selected all of our items. And then it says enter height. We can actually just type in 2. Okay. The other way to do it is to type it in, and it's extrude, EXT, okay, for extrude. And again, we'll pick the item or items, and then we can enter the height that we wish. Next, we're going to use the slice command. Okay, so that'll be under edit. And we can find the little knife here. Slice. Okay, we'll pick the object or objects that we want. When we finish, we press enter. Notice that it is giving us instructions of what they want. So select the objects to slice. When we're finished, I'll press enter. And it says pick the first point. I'm going to pick this point. And it says pick the second point. I'm going to pick this point. It now says specify a point or destination size. What it's looking for is, and we can read down here at the bottom, select a point on the destination side that you want to keep, or I can press both to keep, or B for both to keep both sides. So if I actually wanted both pieces, I could. But right now today, I only want to keep this side. So now we've created a nice wedge. All right. So I'm going to rotate this around so I can see the hypotenuse side. And Yeah, so we're going to create a new user coordinate system. And the way we're going to do that is this little pull down here. And we'll say new UCS. And the first thing that we want to do is we want to pick our origin point. And so I'm going to pick this as my origin point. And then I'm going to define the x-axis and then the y-axis. And you'll notice that what it's done is it's taken my little grid and laid it on top of here. Now anything that I draw is going to be on that plane. This is important when we go to draw things that we have our coordinate system set up so that we're able to draw on that. See, otherwise, if I try to draw a circle here, it just defaults to our work plane. All right. Okay, so now we should name this in case we ever want to come back to it. And so the way to do that is we go up to our coordinates little drop down menu here. We're going to find our named UCSs. And we have one that says unnamed. We're going to right click on it and rename that as height. And say okay. Now over here, if we do our little drop down, we see that we have our world coordinate system, we have height, and we can always create yet another new one. This means that we can go back to this if we need to. All right. Okay. So I'm going to rotate this around so I can see where it says top on my view cube. What this does is it squares everything up. So I'm looking down through my part on my work plane. Okay. And we're going to create a half-inch circle on the midpoint of this line. Okay, so this is going to be something kind of cool. So I'll pick the midpoint here, and I want a diameter of 0.5. Notice that it didn't draw on my work plane, that it actually drew that circle, okay, parallel with my work plane, but it moved it down to this feature that I picked, which was the midpoint of the line. One thing that's really important is to understand that when you are drawing, it's going to literally grab the feature and place the object that you're drawing on that feature. So now we're going to take this and we're going to extrude, okay, that object, and I'm just going to pull it so that I make sure that it goes all the way through my object. I don't really care that it goes too far, and the reason is we're going to use the Boolean subtract. Okay, so let me rotate this around a little bit better. Okay, good enough. And so when we're subtracting, the first thing that you want to do is select the object that you're sort of your base. Okay, and I'll press enter, and then I will select the objects that I'm going to remove from the original object, in this case this one, and I'll press enter. Anyway, so now what we've done is we've created a hole that goes through our wedge. So it's a little bit difficult to see what's going on here, especially when things get a little bit more complicated. There's some definite shapes that in wireframe look very confusing. And so there's a couple ways that we can change how this looks. One way is our little view layer here. We can do a little pull down, and we can choose perhaps shaded with edges. We can also go to visualize and find the same objects here. There's a lot more options if you're actually in this menu. But at the end of the day, the idea is to be able to just see this in a shaded format. Okay, so we're going to go back and change this back to wireframe for a minute. And I want to create a bit more geometry. So I'm going to zoom in here. And I'm going to draw a line from this edge to this edge, and then I want to offset this line by 0.25, and it will only allow me to offset lines. It won't allow me to actually grab that other geometry. Let's do that again, and I'll grab this corner, and I'll offset this same distance. Okay, something like that. And we'll offset one more time. Offset 1 inch. We'll grab this guy and offset him over. And this time I'm going to create a circle. Okay, but I want a 2 point. So I'll press the little down arrow and grab 2 point. And so I want a circle from here to here. And then I want to trim this up so that what I end up with is a semicircle. I can then erase these objects that I don't need. And we should have something like this. And if I try to extrude this the way it is, I'll grab these two objects. Notice that it doesn't really give me a solid. What it gives me are two surfaces. And if I hover over it, it actually says that this is a surface from an extrusion as opposed to a solid. And so that's no good. Okay. And so what we need to do is we need to create a solid closed entity. And so the command I'm going to use here is PEDIT. And the first thing that I need to do is select a line. And then I do want to turn it into a solid object, or a single object. And I'm going to join. I'm going to join that and that. And I'll press enter. And enter again. And you'll notice now when I hover over it, it doesn't say that it's a line segment. It says that it's actually a polyline. Polylines can be extruded. All right. So now I'm going to break one of my cardinal rules, and I'm going to change the color. Now notice if I double click on this solid object, it opens up our quick properties menu. In this case, I'm just going to change the color here from white. We'll do a little pull down, and I'll change it to red. Now we're going to use the Boolean operation. Here we go. And so we're going to union. I'm going to grab this one and this one, and then I'll press enter when I'm finished selecting all of my objects. Notice that it is now one object. Now, just noticing in my instructions, it used to be that the color would change, but it seems to be fixed for, if you will, for the new AutoCAD 2020, so we won't worry about that. I've opened up our second lecture. This is on layouts. There are a couple ways that we can create a layout in AutoCAD for 3D objects. Some of them are better suited for some applications and others for the rest. And I'm going to show you one of my favorite objects for demonstrating CAD, and the two ways that we can lay this out. Okay. So this shape is my favorite because it satisfies three conditions. If you look from the top, it was a circle. From the side, it's a triangle. From the other side, it's a rectangle. And so when we're looking at geometry in 2D, there's no way to confuse how you're looking at this object. The first way to create a layout is to use viewports. So we've dealt with viewports a little bit. There was one created in our basic geometry, and this little video or clip will show you how to create 4 viewports on a single entity. And so what I'm doing here is I'm creating a rectangle that's going to represent the outside border. Then I will create a line about the midpoint horizontally and one vertically. And then I'm going to create a rectangular viewport. Okay. Notice that I'm in the layout tab, and I'll create 4 of these. Okay. And then by double clicking inside or selecting the model tab, I'm able to zoom it out and rotate using the view cube to my different angles. Okay. And then I get some isometric view here. Note that it's really important to keep your vertical and horizontal lines matched up. So for example, if you look at the left side of the part, it actually lined up with the left side of the part. The bottom matched with the bottom. You don't want them just higgly-piggly all over the place if you can avoid it. All right. And so that's fairly simple way to create viewports using the viewports. This way is a little bit faster and easier in my opinion, but it does have its drawbacks as well. And so, there we go. In this case, what I'm going to do is in the Layout tab, I'm going to go to Base from Model Space, and it actually brings in a representation of the object. And you'll notice that I'm able to just drag this around to create my front, my top, my side, and my isometric view very quickly. I'm able to also manipulate how this part looks. Okay, so I can change a lot of the properties to do with that. Okay, so now that we've seen our 2 methods for creating layout views, what I want you to do for your homework assignment is to go through the instructions step by step, and we're going to try to create a metric drawing. And so there's a couple ways to do this. This is definitely the harder way. The easier way I'll talk to you about later, but to change a drawing, I want you to give this an attempt. Okay, so you're going to take a blank drawing and we're going to change the drawing units, okay? And so you literally just type in units and it will change most of it. The easier way is to actually start by opening up a drawing using a metric template. Okay, but you can give this a shot. I'm not too awfully worried about it being in metric, but I do want you to attempt it and follow through. What we're trying to do is we're going to create a little circuit board. Okay, not very complicated, just has 3 holes in it. But the idea is that I want you to create 2 different layouts in one drawing. The first layout is going to be using viewports, and do your best to line them up. Make sure that you lock them. Once you have created these 2 viewports, lock both of the viewports. The second layout, I would like you to use the base command. So basically follow through what we just did and give it a shot. Okay. Now the third part, and this can be preferably in the same drawing, is I would like you to draw this object. How you get there is absolutely up to you. Today we're starting to move from instruction-based to task-based assignments. The idea is that you will figure out how you want to do this. So I'll give you a couple pointers, or not pointers, a couple examples of, you could create a block and then subtract this inside piece. You could create this L shape and extrude it. You could create 2 flat plates and union them. Okay, it's completely up to you. But what I do want is these holes, actual diameter. This is the symbol for diameter. Okay, don't get that confused with your radius. I would like you to have them in the right place, and I would like them dimensioned. Okay, and if you could put it on the actual template, that would be fantastic. And so, like I say, if you're not able to convert over to metric and you want to do it the other way, I can live with it. It's nice to be able to convert your drawing into metric, but if it's a problem for some people, it's very finicky. If you can't get it, I will understand. When you make your submission to the Dropbox, please leave me a note saying I couldn't make it, I couldn't do it, or if you were able to, then it's no problem. All right. Again, if you have trouble with the homework assignment, do feel free to give me an email, and possibly if there's more than one person requiring more assistance or more clarification on how to do something, I can always post another video. Okay. The third portion of our lecture today has to do with the CAPSTONE project. CAPSTONE project is a way for us to ensure that you have learned and can apply the knowledge that you've gained from the course. This CAPSTONE project differs from some of the other classes that you will have in that it is split up into 3 distinct portions. Each of them tells me something about what you've learned and will help demonstrate your skills to prospective employers. The first portion of this is a 3D custom part. Now, we typically try to print these on the 3D printer, but that's become problematic over the past few years because of time or access restraints. So you can ignore the size if you want, if you don't want to print it. If you do want to print, some options are available to you. If we're not able to access the printers in the school, there are printers available at most libraries, as well as there are some in the college. And when we do have access to them, you could absolutely take your file and print it. Now, on the topic of 3D printing, I always laugh to myself when I see people go to the library to use the printer and they use the canned parts. It's not something they've created. They just think that printing something is really cool. In my day job, we 3D print all the time. So for me, it's lost its novelty, but absolutely creating your own geometry, something that you've made, for example, my little yin-yang symbol here using positive and negative space, is something that you could print and then glue onto a keychain, for example. Okay. If you are planning on 3D printing this, realize that size does equate to cost, and if you can get something small enough that will fit into the printer, that's awesome. Anything that you do make, for me though, make sure that it is fit for public consumption. I don't want anything rude or offensive being sent to me or involved in my course, because that's a whole lot of trouble that I don't need or want. All right. I will give you some more details on this, but now that we're starting into 3D, I really want you to start thinking about it and start playing with it. And the Capstone project isn't something that you should wait until week 10 to start. You should really be thinking about it now. The second portion is a full set of drawings. This is going to not be this drawing. This is an example, but we're going to take our assignments moving forward, including today's, and start to create an entire drawing package. This is going to be a power supply, and everything that we learn is going to get applied. And so as you are receiving feedback on your assignments, you should really be fixing up the mistakes, improving upon it as we go. This will associate 30% of the Capstone project, just taking the files that you've already created and fixing them up. Okay. The third portion is worth 40%, and you already have the skills for this, and that is a 2D drawing. The reason for the weighting is that I expect perfection from your 2D drawings. You could get started on this right away. The instructions are on DC Connect under Capstone Project. And what we're creating is a reversing motor contactor. I have no expectations that you understand what that is or how it functions. What I do expect is for you to be able to follow the drawing and recreate it. The idea being that it is absolutely immaculate. Why is there so much emphasis on this? For the portion of this class that is taking the electromechanical, I really expect you to produce drawings for your other professors in things like controls that absolutely would be industry accepted. All right. If you have any questions or comments, please send me an email right away. If it's something that lots of people are having trouble with, I can absolutely make another video and we can do that. If it's something that you can find the solution to yourself, I encourage that. The reason being is that if you learn how to use the help menu, if you learn how to use Autodesk services, you will absolutely be able to go much further than what I teach in this course. You'll be able to continue to learn. So that said, I am here as a resource. Don't let your inability to find an answer readily prevent you from doing your homework. Okay, I'm not saying don't send me an email. I'm saying try the help menu first and then contact me. Okay. Now, as far as the CAPSTONE project, I want you to start thinking about it. I want you to start vetting out some ideas and really think about it and have fun with it. This is supposed to be something that shows off your ability and hopefully your passion for creativity. Okay. Again, questions, comments, email me right away, and I'll do my best to answer you promptly. All right. Thanks, and good luck, everybody. See you next week.